Okay, we're on lesson 63, talking about rational numbers, non-terminating decimals, and percents. Okay, and with fractions with negative exponents. Example 1 says to express 2/3 as an equivalent decimal and a percent. Then express 2/3 as a decimal round to the thousandths place. And I almost forgot, don't forget to write down the objective up here. So we want to express 2/3 as an equivalent decimal and percent. Well, remember, if we want to express a fraction as a decimal, we simply take the numerator and divide it by the denominator. Okay? So if we want to take 2/3 as a decimal, oops, I keep doing this here. Let's get my thicker pen because I like that. Okay, 2/3 as a decimal, we're going to take the numerator and divide it by the denominator. 3 doesn't go into 2, so we put a 0 and a dot. Keep our decimal point. 3 goes into 26 times, and we subtract it 18. And we notice that this is going to repeat itself because we've got the 20 repeating. So it's 0.6 repeating as a decimal. Okay? And then we want to express it as a percent. Well, to express a fraction as a percent, we take that fraction and multiply it by 100%. And we always put, when we multiply with fractions, we put 100% over 1 and multiply across. 2 times 100% is 200% over 3 times 1 is 3. Alright, then I need to take 200 divided by 3. And 3 goes into 20 6 times. Subtract and get 18. And bring down the 0. And 3 goes into 26 times. Oops. And if we were to subtract that again, we get 20. Put a decimal up here. And I'm going to get 6 again. And what happens is 6 is going to repeat itself. So once I get to the 1 decimal place, I can say that the decimal just keeps repeating. But I've got to at least have 1 decimal place before I can put a repeating bar over the top. So it's the same as 66.6 repeating percent. Or we just found out that 0.6 repeating is 2/3 is decimal, so we can say it's 66 2/3%. Either way. And then we want to express 2/3 as a decimal rounded to the thousandths place. Okay? So I want to take that decimal, 0.6 repeating, and round it to the thousandths place. Well, thousandths place is 3 spots, because here's the tenths place, the hundredths place, and the thousandths place. And if we want to round to this place right here, we need to go 1 extra spot. Until, what's the 6 tell us to do to this 6? Well, we round it up. Okay, so it becomes 0.667 as a rounded decimal. Now we need to think about what the most exact answers are here. Okay, a rounded answer is never the most exact answer. It's the easiest to work with, but not the most exact. So this repeating decimal is an exact answer, this is an exact answer, and fractions are always exact answers. Alright, so again, when we want to round, we would only usually do that when they tell us to, or if they tell us to estimate something. Alright, let's go on to another problem. Okay, example 2 says express 16 2/3% as a reduced fraction and a decimal. Well, remember, we got 16 2/3%. Remember when we learned about percents, we said percent literally means out of 100. So this is the same as 16 2/3 out of 100. Okay, now this looks funny, but whenever we mean out of 100, that's the same as dividing by 100. Okay, so we can take 16 2/3, whoops, and since it's over 100, that means divided by 100. Okay? Well, remember, when we're dealing with fractions and we're doing division, we need to multiply by the reciprocal. So the first thing I need to do is convert this to a mixed number. That's going to be 50 over 3. because 3 times 16 is 48, and 48 plus 2 is 50 over 3. And then we're going to multiply this by the reciprocal of 100, which is 1 over 100. And after some cross-canceling, 50 and 100 will reduce to 1 and 2. And after multiplying across, we're going to get 1/6. So there is 16 2/3% as a reduced fraction. Then we want to make that a decimal. We're going to take the fraction part and make it a decimal. So 1/6, we're going to take that 1 divided by 6, and 6 goes into 1 0 times. We have the decimal point, and 6 goes into 10 once. Subtract and get 4, and bring down a 0. And 6 goes into 46 times. 6 times 6 is 36. And we get a 4 and a 0 again. So that means that 6 that we just had is going to repeat itself. And that's the only digit that repeats itself because the 1 did not. Okay, so we're going to have 0.16 repeating. Only put the bar over the part that repeats. And we'll move right on to example 3. Example 3 says to arrange these numbers in order from least to greatest. Now remember when we talked about arranging numbers, we wanted to convert them all to the same format. And the easiest format is usually decimal. Okay, so we're going to convert all of these to decimals. So we're going to take 4/5 and make it a decimal. We're going to take 83 and 1/3% and make it a decimal. And then we got 0.83, which is already a decimal. Okay, and then we're going to compare those and arrange them from least to greatest. Well, 4/5 as a decimal. 4 divided by 5, that's 0. Point, and 5 goes into 48 times. Okay, so far we've got 0.8 and 0.83. 83 and 1/3%, remember that's 83 and 1/3 out of 100. So we're going to take 83 and 1/3 and divide it by 100, which is the same as multiplying by the reciprocal. Okay, well 83 times 3, that's 249, plus 1 is 250 over 3 times 1 over 100 multiplied by the reciprocal. Why would And if I divide 250 by 50 and 100 by 50, I can reduce this. 100 divided by 50 is 2. 250 divided by 50 is 5. And by multiplying across, I get 5 over 6. Okay, still not a decimal. So now we need to make this a decimal. So I'm going to divide the top by the bottom. 6 goes into 5 0 times with the decimal point. 6 goes into 58 times. Multiply and get 48, and subtract, and we get 2. Bring down a 0. 6 goes into 23 times. Multiply and get 18, and we subtract, and we get 2 again. We just did that, so the 3 is going to repeat itself. Alright, so we've got 3 decimals, 0.8, 0.83 repeating, and 0.83. Well, it doesn't help us to have them with different decimal spots, okay, meaning there's 1 decimal here and 2 decimals in each of these. And also if I leave each of these with 2 decimals, they look the same. So let's extend these out to 3 decimals apiece. Okay, so 0.8 is the same as 0.800 if I go to 3 decimal places. 0.83 repeating is 0.833, and then 0.83 is 0.830. So by looking at these, we want to order these from least to greatest. Okay, so the least one is the top one, 0.8. Then after that, the next one is 0.83. And after that, it's 0.83 repeating. And the last thing we need to do is put these forms in the form they were originally. Okay, so if I look up here, I'll move this back in a second, but we've got 4/5 was 0.8, so my first number is 4/5. 0.83 started as 0.83, and the other one was 83 1/3%. Okay, a lot of work, but notice again I converted each of them to a decimal and then compared those decimals. Okay, that's the best way to go about doing this. And let's move on to the next example. Example 4 says the incumbent received 41 2/3% of the 1,260 votes cast in the town council election. Okay, an incumbent is just somebody who's already in office. So for example, in this last election, the 2012 election, President Obama was the incumbent because he was already the president. Okay, it says describe how to estimate the number of votes the incumbent received. Then calculate the exact number of votes. Well, if we wanted to estimate, okay, the best way to estimate would be to round this percent off. Okay, so we could round 41 2/3% to something close, like 40%. Okay, and then find 40% of, and we could round the 1260 to 1200. And that would give us about how many votes. But this says we want to calculate the exact number of votes. So we're going to take 41 2/3%. Of means times 1,260. Alright? Well, there's many ways to do this, but first we need to be able to get rid of this percent sign. So I'm going to go ahead and change 41 2/3% to a fraction. Okay, so we're going to take 41 2/3 over 100, which again is the same as 41 2/3 times 1 over 100. And 41 2/3, well, 41 times 3 is 123, plus 2, that's 125 over 3 times 1 over 100. We can cross cancel, because I know that 25 goes into both of these. 125 divided by 25 is 5. 100 divided by 25 is 4. And if we multiply across, 5 times 1 is 5, and 3 times 4 is 12. Okay, so 41 2/3% is the same as 5/12. Now I just need to take that and multiply it by 1,260. So I'm going to take 5/12 times 1,260 over 1. Okay? Well, I can cross cancel because 12 goes into 1,260. So 12 divided by 12 is 1, and 1,260 divided by 12 is 105. And then I just multiply across. 5 times 105 is 525 votes. So again, what we did is we took the percent and changed it to a fraction, and then multiplied. And we've got one last example. Up here, this should say objective 2, sorry. And it's to simplify fractions with negative exponents. Okay, so here I've got a fraction with negative exponents. So I've got 1/3 to the negative second power. Well, anytime I've got a negative exponent, remember that told me to move things to the opposite side of the fraction bar. Okay, so basically what we're going to do is take this and just flip it over on top of each other and make it a positive exponent. So 1/3 to the negative second is the same as 3 over 1 to the second power. Okay? And 3 over 1 is the same as just 3. So this is 3 squared. Alright, and if we want to completely simplify this, okay, 3 squared is 9. So again, simplifying with fractions with negative exponents is pretty easy. We're going to take this and make it its reciprocal, flip it over, and make the exponent a positive. Okay, so again, flip over the fraction, make the exponent a positive, and then simplify. And that's it for your lesson. Happy homeworking.